Hello, I'm Sumit, and you're watching or listening to the nethero podcast. This is a podcast for you if you care about what we're doing to the planet. You don't have to be an eco-warrior. We believe business is the solution to making things better. But we're for people who want to make that difference by either cutting their emissions or coming up with ideas that can help us do things a bit better. We've featured politicians, academics, lots and lots of business people, entrepreneurs, inventors, and of course people who are just interested in doing the right thing. So sit back, listen and enjoy, and make sure you subscribe to the podcast. Please share it with your friends and colleagues, and you can always check out our two websites that cover all of this, Energy Live News and futurenetzero.com. This podcast is purely editorial, so sit back and enjoy this week's episode. Carbon. You're made of carbon, I'm made of carbon, the plants are made of carbon, we're all bloody made of carbon. The problem with carbon is we all know that there's just too much of it being released. And so over the last few months, you could not have missed it, the UK government has been really pushing the button on carbon capture. It's something that's happening across Europe as well. But carbon capture we've covered on the past before, and you might say, well, why are you doing it? Because it is going to become a bigger and bigger player. The IEA recently put out a report saying it'll be a fundamental part of how we can see the pathway to net zero. But capturing it, sticking it underground, well, that's one solution. The other part, if you get its full title, carbon capture, utilization and storage, are we doing enough about that? Well, today I'm joined by a very special guest because it's her birthday. So I've got to be very nice to her. She works for a company that is doing a lot of this in a very unusual way, trying to capture the carbon to put it into building materials, particularly concrete and stuff like that. The company's called Pebble, which is sort of like Dutch and Nordic for pebble. And her name is Ana Luisa Vaz. I would say buongiorno. I'm not great with the Portuguese. What is it? What's the ciao? I'll do ciao.
Bon dia.
Bon dia. Happy birthday, by the way.
Thank you very much.
So let's start with a little bit about carbon capture, which I've just said in that terrible intro that I do. But for the audience, people will have heard of carbon capture because it's been around quite a long time. But can you take us through, Anna, just the kind of main ways we can do it? Because people get confused. They hear about things like direct air capture. They hear about, sequestration. They hear about kind of absorption through materials. Simple sort of science for idiots like me. How do we capture carbon now?
Yeah, so right now, maybe one step back on that. So the understanding why the carbon capture and utilization, any of the terms. So I think it's being very clear. We passed the mark that we are putting carbon in the atmosphere. So there is very intensive to the carbon negativities or zero, which means companies need to reduce, all of us. But I think it's also clear we need to keep evolving. So AI technologies, we will keep producing carbon. So these technologies comes as a reverse effect. So you can actually do something on the emissions that we do because there is no other way. So carbon capture, as I said, so basically the philosophy there is try to contain the carbon before it stays in the atmosphere. And that you have two ways, or you utilize it in something useful. You make materials out of it. And then you have there the examples of SAFs or materials like us at Pebble. Or you actually can store it under the ground, right? Basically on several locations in order to permanently contain the CO2 instead of being available to the atmosphere.
What's the technology how do you actually capture the carbon?
So we actually use what we call a hack in nature. So nature has been doing that for many, many years. It's part of the carbon cycle. So what we do is we have a proprietary technology that uses the carbon actually and permanently stores in what we call enhanced mineralization. So we accelerate the process and store it in a mineral, in a rock. And instead of the nature will take thousands of years, we do that in a couple of hours. And then what comes out is a mineral, actually base material, which can then be used by the nature and the composition in construction materials as a partially replacement of cement.
You're basically talking about mineralization, right? Which is normally, and this is my geography from 100 years ago, the carbon is in the air. The rain sort of it falls down and it dissolves in the rocks, and is that basically what's going on in
Yes, it's exactly that. So you use CO2, you use is water-based process indeed, and then you
yeah,
have the rock, as you said. The combination of the three components in the specific setup with our proprietary technology in accelerating the process. So we have certain types of catalyst, and we reuse the energy. It allows that the carbon gets permanently captured, so it actually changes phase from what is before CO2, it becomes a carbonate. So, and
right.
that is the material that actually is then stored permanently and is very stable.
The rock that you're using, what is it? What's the base material? I mean, don't give me away the secrets. I'm sure you've probably got it, but is it just something that is out in nature and you do something to it?
Yes, you can use different sources, right? It's silicon-based minerals. So one of the example we use, it can be olivine, but there are other types. You can also use what is called waste streams for processes from steel processes as well. So many types of materials can use as long as the composition is correct. We are investigating in our R&D roadmap several of them in order to scale the technology. So it's widely available, being from nature or from waste streams of existing processes.
Right. So you're not having to dig anything up. You're not mining this rock and stuff like that to do it.
We need both because the drill here you need to scale. So the industry, specifically the building industries, you're producing millions and millions of tons. So actually, concrete is after water is the most used material worldwide.
Yeah.
If you want to really make a dent on the impact of decarbonization, you have to go big on scale.
Right.
So what we try to do is we make the process as efficient as possible. So it's called in the technical terms the LCA of the full process, and then that still becomes negative. That's what we are trying here to prove. So if
Right.
you go to all the steps, we try to be as energy efficient as possible, even if you have to mine raw materials, in order that the all overall is still carbon negative.
Okay. So, I mean, this is something that needs to be clarified. So, there is some work that you do where you have to go and get something, mine it, whatever. But what you're saying is you've tried to ensure that the carbon emissions, the embedded carbon of your processes, is still giving you a negative result at the end.
And that's the only way. And similar to other
Yeah.
technologies that you use weight streams, so when you do the full mass balance of the carbon, so you
Yeah.
actually track the carbon from beginning to end, you need to
Yeah.
assure that after the process, you actually still in the negative framework, basically.
I think I've got some facts which may even have come from your company about 40 billion tons of concrete made annually. And I've covered concrete before in the podcast. And then it's about sort of 8 to 10% of emissions. Now, a lot of people are saying that actually, do we need it, right? Could we move to wood again? Could we move to bamboo again? And these sort of more kind of sustainable biomaterials. And we've covered stuff like that. But I think the fact is, realistically, we haven't come up with anything better than concrete, have we, really, for structural load?
It's very versatile, it's very cheap. We would love to come back to. I'm a big lover of food. I worked with architects
Yeah,
before. The buildings looks beautiful.
it does, yeah.
They do look beautiful, but I do think if we want a tree takes 20 years to 60 years to get mature. So if you look to the growth of population, saying that we come back to a material that has such a long lifetime, it's just not realistic
Yeah.
and also cost effective as well. So I think we need to just rethink the way we have the industry working and rethink the processes. And if you add all the technology we've been developing, so concrete making is there from 100 years. One just have to look with a different eyes and say, what can we optimize in this process to be still cost effective, but actually have an eye on the environmental footprint. Like many other processes, we as humanity needs to rethink, right?
Yeah.
As much as the natural materials are part of it, so I'm totally in favor. I work many, many years with natural materials. I think we need also to be realistic if you want to be side by side with humanity growth, right? People need to have houses to live. We will continue growing infrastructure. We need to be realistic that the only way to do it is having competitive solutions as well. So concrete is definitely still going to be there as for many, many years.
So how does your technology work? And I know you've built a demo plant, but would the idea be that your plant goes and is like a little unit that sits where they're making concrete, or do you stick it on to capture the gases from the chimneys or whatever that the concrete plant is making? Can you talk us through the idea of how this would work?
So the reality, we are the second phase of that process. So there are many, many companies doing amazing job on capturing CO2. So you have DAC processes, what is called direct air capture, and source point capture. So we just collaborate with them. Yeah, we have open
Ah,
collaboration with it.
okay.
And we are agnostic to the source of CO2. For us, any CO2 will work. Our focus is actually how convert CO2 in a material that can be reused and
Gotcha.
permanently captured, so it cannot be released to the atmosphere. That's the core of the
So
technology here.
you're actually getting the carbon already captured
Yes.
from other plants, right?
Yes,
Got it.
we collaborate that. Yes. So as we believe that focus is extremely necessary and the technology, it is available out there. So we focus on the second part, which is we take that CO2 that is captured and then we actually include it in our process, right? And then we make a material that can be used as for the next step, which is building and construction. So how does it work? So the material is not a full cement replacement, it's partially replace a cement in the formulation
Okay.
of concrete. So cement is the big contributor, the largest contributor for the emissions in concrete due to the old way we make cement, right? And by just reducing a percentage of cement in the full formulation, you actually have a large impact. So about 40% less embodied carbon, up to,
Right.
depending on the replacement that you go. And then, of course, it's very linked to applications. And I think it's important to understand, right? It's very different to make a brick for a pavement than to make a structural bridge. So one needs to be cautious. And I come from a product part of it. So I'm very cautious on the customer requirements. So, and understand what is the customer needs. That's actually my role here and bring it back to the organization. So we fine tune our chemistry to deliver the customer and the
Okay. Right. So if someone says to you, look, Anna, I want to use, do you give it a name, your captured carbon thing? Has it got a name?
We are right now having a revaluation on the branding. Right now we call it pebble material. It soon it
Right.
will have a
Should we have a snazzy name? All
yeah,
right, okay. So I'll call it Anna's Rocks for now. All right, Anna's Rocks, right? You
that's
take
good.
Anna's Rocks and you go, I can make it so you can use it for paving on the streets. But then you can say, oh, actually, no, actually, I need it for a bridge, much more stronger. You can reformulate Anna's Rocks to do that. Is that what you're trying to say to me?
Yes, so we do what we call solution provider to the customer. So we do a co-development. We work
Ah,
together with the customers and we use also high technical tools that help us to formulate, to assure that we have
okay.
the right footprint, and of course we have eyes on the costs as well, which for us it's a longer term an exercise as we're scaling. But we look to the customer application, right, the performance, and we advise together what is the best formulation with our material in to actually respond to the needs. So for example, if you have pavement, I will say you can replace up to 30%. I see no performance impact. If you are a bridge, I will be at this stage more careful and assure that we do a full validation tests with the certified labs. This is what we call rapid prototyping and interactive product development, right? Instead of us being locked in the lab and study
Yeah, I get
something
it.
and then we go to the market and they say, not sure. We do together with outside knowledge and we directly listen our customers and the needs that the market has.
So you're basically needing to, at present, you've got a demonstration plant, yeah?
Yes, yes, we're very
Where,
excited.
where, where
Yeah.
was that?
So it's in Rotterdam, and we actually, as I will say, turned the button a couple of months back. So it's been an amazing. We delivered on budget and on time on
Cool.
18 months. So this is quite unique. Our plant is about capacity 1.5 kilotons product,
Right.
and up to our knowledge is the first carbon storage at this level and utilization that actually was launched. So very happy.
So the plant is there.
Yeah.
You go and get. So let's make it very simple maths for our audience.
Yeah.
Someone else has captured the carbon, and they give you carbon capture material 100%, right? Let's call it
Yeah.
100%. After you've done it, how much of that carbon capture have you actually captured? So if there's 100 bits of CO2, and this is no stupid science, but anyway, there's 100 bits, how much will you capture in your mineral at the end of it?
So in 1 ton of material, about 300 kgs is CO2
Right,
captured
okay.
permanently.
So about a third, then roughly.
Correct.
Okay. So what happens to the rest? Is that then being released? What are you doing? We're trying
We,
to
we feed it back, right? We just use all
okay.
the CO2 and then we continue the process. It's a continuous process.
Got you. So it's a
So
loop. It's a loop to keep
it's
going.
continuous, so we keep and we monitor because that's very important in when you're trying to solve a climate tech process. We really trace the carbon, so we have a lot of measurements in the plant to trace where the carbon goes. So we have our eyes on the carbon, so we circulate back to assure that we have the maximum efficiency of the process. Of course, this is going to be an
Yeah,
optimization
I
with
understand.
time.
Yeah.
But that's basically what we try to do. We are very cautious of what we are here doing and trying to
Yeah.
optimize the process to the molecule of the CO2 tracing.
And in terms of your own footprint for the plant, so obviously you
Yeah.
need to power it and all that. Are you trying to power it with renewable energy? What are you trying to do to try and reduce your own footprint?
Yes. So that's very important. So there are three main criteria there. You have the energy use. So yes, it needs to be, of course, coming from green sources. You have the logistics, normal footprint. So we are very cautious on the location. We are now in this feasibility study where we're going to put the next factory. It needs to
Right.
be close to or the source or the customers because to minimize that. And we have a team dedicated to check what's the best location there to minimize that.
Yeah.
And then you have the process efficiency. We have also a team dedicated to look to the process efficiency. So if I give you the long-term view, we target to arrive to what is called minus 200 kg of CO2 per ton of product.
Wow.
We at this stage are in this optimization phase, and we hope to arrive there in our next plant.
What does the material come out as? So does it come out as kind of a rock type material? You have to put it on a lorry and you send it to someone to make into concrete?
It really, and then by the nature of this, it really looks like cement. We don't have any extra
Ah,
grinding step. It looks like
ah.
a white powder, as fine as cement.
And so they can use it. They can use it straight away. They can put it
Straight
in.
away. We call it a drop-in.
Ah,
So you
okay.
can just take the powder and put it in your normal formulation. You replace a bit of cement and put our story mineral in it, and it works exactly the same. No changes needed at the customer side, which I think it's
That's
one.
very clever. Yeah, yeah. Okay. So they're getting the source material just to be used straight away.
Yes.
Okay. So how much have you done testing and how sort of robust is this? Because it's always difficult with new science and new processes. So you said you've been running it, a few months now. What's been the feedback? Has anyone actually used your, I'll call it Anna's rocks for now,
Yeah,
in
yeah,
in slabs? Have they said, yeah, it works, it's stable,
yeah.
it's not collapsing? What's going on?
So to give you a bit of numbers behind that, so we have about right now 150 leads to collaborate. So a lot of demand. We are in this lucky position, a lot of demand. For me, it's also a translation that the world sees the need of
Yeah,
rethinking the
yeah,
industry, which I think is very positive.
yeah.
We move to, because of course we get to human blockage there. We cannot supply to everybody. So we have 40 tests running from 1.5 years when I joined the company. And from that 40 tests, actually, we deploy field commercial projects for. And
Right.
coming now to the next. So what I mean field commercial, actually existing buildings that have our material inside, and we prove that we reduce the embodied carbon and we permanently store. So we made a building in Spain, a partially building. We built 4 walls there. We made flooring in Paris. We made another house here in the Netherlands, and
And they're all standing. They're all still
they are
standing.
all standing. And I invite your audience to actually check out our channels, our social channels. You have statements from the people that collaborated
Lovely.
with us, and I think so far everybody is very happy. I think it helps the way we are open to
Yeah, yeah. No, I
customers.
get it. I get it.
And so far, it's been quite successful. It does help that it's a drop-in type of material.
I was going to say.
So yeah,
Mm.
so far the results are amazing. So we keep delivering the two propositions, which I think is very important. One, we reduce the amount of embodied carbon in the structures, right? Less cement, less embodied carbon. At
Yeah.
the same time, and that's the uniqueness, we actually physically store carbon in walls and floors. So we call it carbon sink. That's how it's known. Basically, we store it forever in physical buildings.
Do you think, obviously, I know you're going through funding, you want to scale up, which is great, but is this something that, because there's always a big thing for me, is that, and I think this is where politicians, frankly, screw it up too much. You can't do this unless everyone does this. So the developing parts of the world where the cost of materials is higher for some and cheaper in other ways, they may just not have the technologies or whatever. Is what you've made here with Pebble really a solution for the Western developed nations, or can you see this working as nations are developing so they can skip, a technology step, or is it just much more kind of designed where you've got to have more kind of levels of sophistication that you might not have in, say, sub-Saharan Africa or parts of Southeast Asia?
Yeah, to be honest, I think this is a technology that can be used worldwide. But if I make an analogy to other technologies that we deploy, so if you look to EV, to electrical vehicles, there is always a risk factor. There is a regulatory risk factor. There is humans involved, right? So you're building a house, the house needs to stand 50 years, right? So you first need to give trust to the market.
Yep. Yep.
And that is where what we call the west side of the world has to put a little bit more step in, right, to help to prove the technologies. And that's what we are now. Why? Because of course there is economical power for developing testing
Absolutely.
yeah. So
Yeah.
you're bringing trust to the market, and I really hope, touching your point there, and I do a call for action here, that the regulatory sees that need as well and come together with us. So we are
So
happy.
you do think, sorry to interrupt, you do think
Yes.
your technology could work where in developing nations to capture and reduce the footprint.
Yes, for sure, for sure, for sure, for sure. There is no reason why not to.
Right. Okay. To end with, where do we go with this? I'm sure people are probably doing things like this elsewhere. Maybe you're the only ones. I don't know. But it comes back to what we said at the beginning. We are growing as a planet. We're growing with people. We're going to need more of this. This seems to me, what I like about it is a way of going, right. We've seen a problem and we know what's coming,
Yeah.
and we can help reduce what's going to be next, right? So if it'd been around 100 years, we'd have houses with less embedded carbon now than we do, right? So do you see the future being more of this, trying to reduce and reduce what goes in next generation of housing and buildings? Or do you see it also being perhaps a way of going for that full circularity? You take buildings that are being pulled down, you take that material, maybe you can capture things from it and then start to do it. How do you see things going?
I see both, right? We just need to think smarter how to do things. And that means reduce, reverse, anything we can do in the good direction, right? That's the most important thing. So I don't think one solution will solve it. The problem is far too big. We keep growing as humanity, and you only have one confined planet with one confined resources. So we just need to use our know-how to make it better, a more efficient use of resources. And I think in the 100 years you saw we were using resources. Now I think we are all understanding, okay, we need to think better how to do things. So any initiative that will support that path include circularity, reusing materials, bio-based materials, technologies like Pebble. They all together will deliver a more sustainable world. That's basically, for my view, that's how it goes. You cannot just bet your cards in one shot.
Well, there you go. That is the way to do it. So I hope that you're going to have a very nice birthday with a little Anna's Rocks cake made out there. So,
Yes.
listen, Anna, really interesting stuff. I think what Pebble is doing. If you want to check out the website, I'm going to get this right because it's quite tricky for me to. So it's www.paebbl.com. All right. So if you're listening and watching it, look for that. And they've got some pictures of people looking at Anna's Rocks. There you go. That's always good.
Check us out, reach out. We are happy to have a chat on the topic with anybody interested.
Brilliant. Well, you've been very, very, very open, and I thank you for it. Thank you for joining me on the Net Hero podcast.
Thank you. Thanks for the invite. Thanks for the opportunity.
No, not problem. Audience, tell us what you think. Get in touch on social media. You know the score. We'll be back with the next episode very soon. My thanks to Rob for the production this week. Catch you next time.
You've just heard the Net Hero podcast from futurenethero.com. Join us as we help you find ways to cut your carbon footprint as we head towards net zero. Subscribe and follow us on social media. futurenethero.com. Better business, better planet.